All right, welcome you guys. So in 6.1, we talked about systems of equations in two variables. So we were in 2D space, but now we're going to talk about systems of linear equations in three variables. So I will be using GeoGebra's 3D grapher for this. I'm sure there's stuff that's better out there, but this gets the job done. So this will help us get visuals for what we're doing, okay? So a couple things that I want to point out is before we had two variables, and this was a line. Well, now we're going to have an x, y, z. We have three variables, and this is no longer going to be a line. This is going to be a plane. So let me just go plug something like this in here so that you understand, what I mean by a plane. So a plane looks like a sheet of paper. Like it's thin, right? Okay. And it actually extends indefinitely in all directions. Of course, we can't graph forever in all directions. So we graph what looks like this piece of paper, but it's going to slice through space forever, this way forever, down forever, back forever, and forward together. Okay. Or forever. All right. So we're moving into planes now. Okay. We're still going to use the same terminology as far as inconsistent. So if we get no solution, it's going to be inconsistent. And then if we get infinitely many solutions, it'll be called dependent. But let's go and look at some pictures of what can happen and determine whether or not we have a solution, we have infinitely many solutions, or we have no solutions. Okay. So the solution for a system of linear equations in three variables is going to be the point or points where all three planes intersect. So if we look at this one right here, I can see that this teal looking one intersects with like the lime green one in a line right there. Okay, so that's where two planes intersect. And then I can see the lime green and the red intersecting right here. And then in the back, you can kind of see the red and the teal intersecting there. But there's no place where all three lines or where all three planes intersect. And that's what we're looking for. Okay. So we're going to go ahead and say, since there is no point at which all three planes intersect, there is no solution. Okay. And so let's go ahead and classify these using those words we talked about. So since there's no solution, this would be inconsistent. That makes sense, huh? No solution sounds like it would be inconsistent. Okay. And these are not infinitely many, so this would be independent. Okay, let's try the next one. Okay, so we're looking for the spot where all three planes intersect. So we can see that we have the lime green and the blue intersecting there. And we can see that we have the lime green and the red intersecting there. But unfortunately, there's no way for all three planes to intersect because this blue one and this red one are actually parallel. So since they'll never touch, then there's not a spot where all three could possibly touch, okay? So basically, this is going to be the exact same thing as the last one. So I'm just going to copy that and paste that here. Okay, so on this one, we really are getting a spot where all three planes intersect, okay? And this, all three planes would intersect in a line, okay? So that means that we're going to get infinitely many solutions, all the solutions along that line. Okay, let's go ahead and put this out here. Since all three planes intersect in a line, there are infinitely many solutions. Now we're going to, on a problem here, we're going to describe the infinitely many. That's actually kind of a tough thing for students to do. I know in high school, we would just say infinitely many and be done. But I noticed that when I started teaching at college, that they really want you to describe the infinitely many. And maybe they did that in some high schools, I'm not sure. But I know at the high school I taught at, we didn't do that. We're like fine with saying infinitely many. But we're going to find a way to generate all of these points. It's kind of cool. All right, so if there's infinitely many, this is going to be dependent. Okay, and also we have a solution. In fact, we have infinitely many. It is consistent. Okay. Determine whether the following graphs, okay, so same directions. All right, so here we're looking for where all three planes intersect. And actually all three planes are going to intersect kind of in this corner. I like to think of, if you're in a room, the bottom corner on the ground, right? Okay, something like that. And so the red touches there, that like teal one touches there, and the green one touches there. So this would be one solution, right? Okay, so it has a solution. It is consistent. And since it doesn't have infinitely many, it's independent. All right. Okay, well, there's definitely no spot where all three planes intersect, right? So there is no solution. They're all parallel, so they're never going to touch, right? Okay, so no solution sounds inconsistent, right? Since there's no solution, it's inconsistent. And since there are not infinitely many solutions, it is independent. Right. Not having spell checker on these text box really kills me. All right, let's go on to our next one here. Okay, so hopefully you can see that, yes, we do have a solution here. All three planes are going to intersect in that point right there. Okay. Okay, so let's see here. Since it has a solution, it's consistent. And since it doesn't have infinitely many, it's independent. Okay, we have one more here, you guys. So on this case, we actually have coinciding planes. Plane B2 and B3 are right on top of each other. That's what that's trying to show right there. So they intersect in infinitely many spots, right? But because this third plane is parallel to those two, there will be no point at which all three planes intersect. Okay. Then it's going to be inconsistent. And since there's not infinitely many, boy, infinitely is the hardest thing for my fingers to type. All right, since there's not infinitely many, oops, apparently many is too. Since there's not infinitely many solutions, it's independent. Okay. All right, so hopefully you get an idea for what some of these pictures can look like, and that there's a lot of ways to get no solution. Okay, we've had like the triangle looking picture, that first one. That's what I like to call the triangle. That's why we got no solution. We've had two parallel planes. And so since two of them don't touch, there's no way all three could touch. We have all three planes parallel. And the one that we just did where two planes are on top of each other, but the third one's parallel. Look at all the ways to get no solution. And then we had a lot of ways of getting infinitely many too. And these aren't even all of them. I just put a few up here to get our eyes to start to see what it is we're dealing with visually. Okay, Example 2, determine if the ordered triple is a solution to this system. So we need to substitute this in to all three equations, not just into one. It's got to be all three, and it has to work for all three, okay? So the given point has to work for all three planes, okay? Okay, now they write it alphabetically. So this is going to be X, this is going to be Y, and now we are adding in the Z. So we're just going to substitute those in, and let's see what we get. So we have, I'm going to use this top equation right here, you guys, to start it off. So we got 0 minus 4 times -2 plus 5 equals 13. So the 0 is gone. -4 times -2 is +8. And 8 plus 5 is 13. So it's working for the first equation. Let's try the second equation. So 3 times 0 is gone. This is a positive and a negative, so it'll make -2. -2 take away 5 is -7. So that one worked. So what that means is it's on the first two planes. But who knows, it might not be on the last plane, right? And if we look at that last example, a point could be on two planes and not be on the third plane. So we really do have to check all three. Zero will cancel that out. 3 times -2 is -6. And -6 plus 5 is indeed -1. So the conclusion is that the ordered triple is a solution to the system. Oops. All right. Okay, we're going to do, I have to do a lot of examples because I want you to feel the rhythm, to where when you're done with the video, you're like, okay, I totally understand the process. And the thing is, these are such long problems, it's going to take a few before we can finally feel that rhythm, okay? All right, so I think I have, for at least this problem type, 3 or 4. Okay, I have 4. Okay, and honestly, we could do more. So let's go ahead and try this first one. So the process here is, let's go ahead and label these equations as equation, oops, just so we can talk about them. Let me do it in red. Equation A, equation B, and equation C, okay? So what you want to do is you want to kind of scan downward, look at all the X's, look at all the Y's, and look at all the Z's, and kind of decide which variable you want to get rid of. So some good choices. Honestly, all of these seem pretty easy, okay? So some things that I'm thinking is, I noticed that I have a positive Y and a negative Y here. So that might make me want to go towards the Y's, okay? So let's say we choose to get rid of the Y's, okay? Okay, so what we're going to do then is we're definitely going to put equation A and equation B together. And I will say this for whichever teacher you have, definitely for my students, but doing things like labeling it and then writing down which equations you're using is going to help your teacher award you the most points possible if they're giving partial credit on these. If you're sloppy and you don't give them any clues into what your brain was thinking, and it's harder for them to follow, then you'll be less likely to get extra points. So for my class, I'm modeling here what I would like for you to do, because this will be a test where for my classes, I'd like to see the work on it to help give partial credit, okay? All right, so we're gonna get rid of the Y's. So we have X plus 2X, which gets us 3X. And -1Z and -1Z make -2Z and a -11. I'm gonna box that and call that equation D. Now we have to put together two other equations and we have to get rid of y again. So I have some students who will say something like, oh, well, these look easy. That's where it all falls apart. If you get rid of y with the first two equations, you have to get rid of y again with the second two. So my line of thought here is maybe I'll use B and C because they already have opposite signs and we know that we need to achieve opposite signs. Okay, so I'm going to pick B and C. And again, to let the teacher know what's going on here, I'm going to keep C as is. But I need to turn this into a -6, so it'll cancel with the +6. So I'm going to multiply equation B by a 6. So I'm going to put 6 times B here. So that way I know, or the teacher knows what it is that I've decided to do. Okay, so I'm going to do 6 times equation B. So 2 times 6 gives us 12. We know this will be -6. And this will be -6. And then -42. And then we're just going to copy C as is. We'll add downward. So the y's have canceled, and that was key. We need to make sure we cancel the y's again, okay? Oops, a -4 and -43. I'm going to box this and call this equation E. I'm just running down the alphabet, you guys. We already got D, so now we're on E. Okay, so now the two box, the reason I box those is it can get crazy on your paper, you guys. But we're going to put together the two boxed equations now, okay? So we're going to put this one and this one together. So I'm going to go ahead and stack them right on top of each other. And then we can pick whichever variable seems the easiest to eliminate. So the whole reason why we had to get rid of y's in both is that it leaves these two equations with the same variables in them. Since we got rid of y, they both have x's and z's, and now we can put them together. So we basically took it from like a 3-dimensional space problem kind of down to a 2-dimensional space problem here. Okay, so what I'm thinking is that I want to get rid of the z's because I can see that I can turn the smaller number into the bigger number pretty easily, okay? Over here, it's going to be hard to turn a 3 into a 13, okay? All right, so let me think about what I want to multiply by. If this is a -4, then I need this to be a +4. So I'm going to multiply by a -2 because -2 times -2 is +4. All right, so here's what we have. Okay, so this is going to be 7x. The z's will cancel. And then we're going to get -21. That's a great number because if we divide by 7, then that's going to get us a nice pretty whole number. So x equals -3. All right, so now what we're going to do is you cannot go back to the beginning. That's what we're used to with the 2-dimensional ones, right? But if you think about it, if I put that x in, let's say at the beginning, I still won't know y and z, and that'll get me nowhere. So another reason why I box equation D and equation E is because that's where I'm going to take this first value I get. So let's say I pick D. I could have picked E, but D looks smaller than you guys. It looks like more friendlier numbers, okay? All right, so I'm going to go ahead and substitute in a -3 for the x. Okay, so we will add 9 to both sides. So -2z. And then divide by -2. So z equals 1. Okay, so now that we have 2, now we can go back to the beginning. And it looks like we need to find y. So what I would do if I'm trying to find y is I would take them to this one because it already kind of has y, you know, by itself. Here I'd have to divide by a negative when I get done. So I'm going to take this z and put it right here. I'm going to take this x and put it right here. So we've got -3 plus y minus 1 equals -4. And so we'll go ahead and add 4 to both sides. Now, that gets us 0. So we want to write out the solution as an ordered triple. So the ordered triple that would be a solution to this equation, we have to go alphabetically, right? X, Y, Z. So this would be the ordered triple where all 3 planes intersect. Let's go check out a visual for this and see how we did. Okay, so for the first one, it was X plus Y minus Z equals -4. The next one is 2X minus Y minus C equals -7. And then X plus 6Y plus 2Z equals -1. Okay, so let me edit the settings here. I'd like for the colors to be different colors so we can see which plane is which plane. Okay. All right, hopefully your eyes are drawn to right here. As I move it around, you can see that that's going to be the spot where all 3 planes intersect. So what we're going to do is we're going to put in our point, -3, 0, 1. And what do you know? It showed up exactly where we thought those 3 planes intersected. So we've done a great job there. So let's try a bunch more until we get good. All right, so we start off by labeling all of the equations. Equation A, equation B, equation C. And we scan downward and see which variable seems the easiest to eliminate. And I am totally going for the x's here, you guys. So what I'm thinking is we want to put equation A with equation B because x and -x will cancel. So we're going to put A and B together. And they'll be ready to go. So appreciate this. It's not often that this happens, you guys. Just have a moment where you're like, yes. And remember, we call that new one equation D. All right. So now we have to think about what other 2 equations we want to put together. So I'm thinking A and C, because those will also have opposite signs. So we're going to put equation A and equation C together. Okay, so we're going to get -5z equals 15. Well, that's nice. So when we divide by -5, z equals -3. Okay. All right, so remember, we cannot go back to the beginning at this point, because if I plug a z in, I'm not going to be able to find x and y. So we take that z and we substitute it in to one of the boxed equations, okay? All right, so we're going to substitute it in there. So let's see here. So we got y minus -3 equals 5. So we have y plus 3 equals 5. So if we take away 3, we get y equals 2. Now that we have 2, now we're ready to go back to the beginning. And since we're missing x, I'm going to pick the top equation because it already has just an x. It doesn't have a -x. So I'm going to put -3 in there. And then I'm going to put 2 in there. So this gets me x minus 2 minus 2 times -3 equals 4. So negative times a negative is going to make this +6. So this is going to be x plus 4 equals 4. So when we subtract 4 from both sides, we're going to get x equals 0. So the ordered triple, where all three planes intersect, is going to be 0 for the x, 2 for the y, and -3 for the z. Again, let's just go check out a quick picture, see how we did. Okay, I can already see kind of where, oops, sorry, you guys, making you guys a little nauseous here probably. But right here, I can see the purple touches the green, touches the red. So I think our point would show up. I was trying to give us another, there we go. Okay, another viewpoint. Ooh, that's a little bit better, huh? So it should show up right about there. So we got 0, 2, -3. Perfect. Showed up exactly where we wanted it to show up. Okay. Sample C. Okay, so I'm scanning downward. I'm looking at the X's and I'm thinking, oof, I don't think I want to pick those at all. Okay. I'm looking at the Y's and I'm looking at the Z's, and they look about equal to me, honestly. So I would go with either the Y's or the Z's. Okay. So let's say that we pick the Y's. Okay, so I'm going to put, first I'm going to label the equation so we can talk with each other. Okay, so I'm going to put A with B. Now, if this one's a negative, oh, sorry, if this one's a -4, then I want this one to be a +4. So I would have to multiply by a -4. So that's what I'm going to do. I'm going to do a -4 times equation A. Okay, so -4 times 7 is -28. -4 times -1 is +4. Another +4 then. And -4 times 2 is -8. Then we're just going to copy B down. We'll box this and call this equation D. And remember, if you get rid of y's, you've got to get rid of the y's again. So now we're going to put equation A and equation C together. So if the bottom one's a 3, then I want the top one to be a -3. So I'll just multiply by a 3. So we're putting A and C together, but we're going to multiply equation A by 3. Okay, so 7 times 3 is 21. -1 times 3 is -3. And 2 times 3 is 6. All right, let's see what we got. So we canceled the y's again. Oops, go to black really quickly. There's our equation E. Okay, so now we're going to put D and E together. We have to see what we would get rid of. Okay, I'm going to go with the Z's because they have smaller numbers. Now, unfortunately, this is the case where you got to multiply both. So they already have opposite signs, which is great. So I don't have to worry about multiplying by a negative, but I can turn them both into 63. So we're going to multiply them by each other. So we'll do a 7 here. That'll get me +63. And we'll do a 9 here, and that'll get me -63. Okay, 7 times 15. Let's see, 5 carried the 3. I think it's 105. 7 times 9 60, oops, I'm writing an X, that should be a Z. And then 7 times 15, we said was negative 105. Okay. All right, let's try this one. 9 times 17, let's see here. 3 carry the 6, I think it's 153. All right. Okay. Sorry, I'm just looking at my notes and just checking because I don't want to have the wrong numbers. My calculator, I have to renew the license on it, so I don't have it for you guys to look at. Okay, so this is going to give us 48x. These will cancel like we wanted. And then this is going to give us negative 96. Perfect, because 48 does go into 96. Goes in 2 times. So this is going to end up being negative 2. Great. Now we go back to one of the boxed equations. We cannot go back to the beginning. Okay, so let's say that we substitute it in. It doesn't really matter. They both look equally hard. But let's say that we substitute it in right there. So then that's going to give us 17 times negative 2. You know what? I'm going to write it up at the top because we're going to have to do some work to get the y also. So leave that space. Okay, so negative 34 minus 7z equals 1. So we'll add 34, oops. Both sides. Oh, and that's great because that gives us a nice number, huh? 35. All right, negative 7z equals 35. So when we divide by negative 7, we get negative 5. Great. So now that we have both x and z, we'll go back to the beginning. And I do have a favorite equation. I think equation 1 is my favorite. So I'm going to put z in there. I'm going to put x in there. So we have 7 times negative 2 minus y minus negative 5 equals 2. So 14 take away negative 14 plus 5 is negative 9. So we're going to go ahead and add 9 to both sides. So we get, let's see, negative y equals 11. So when we divide by a negative 1, we get y equals negative 11. Okay, so the ordered triple where all 3 planes intersect, the x, the y, and the z. Okay, so I'm hoping at this point that you're starting to get a rhythm for this. Okay, let's try it. Last one of this type. All right, so I picked this one because it's all out of whack. I mean, there's all kinds of issues with it. So before we can even start, we're going to have to like clean up these equations, okay? All right, so if we were to clean these equations up, the first thing that I would do is get rid of the fractions on the top one. So if we multiply everybody, all the numerators by a 6, the LCD, that'll clear the fractions for us. So what we'll end up with is 6x for the first term. Then since 2 goes into 6 3 times, we're going to have 3y when we get done multiplying all those. So we've got minus 3y. And then for the next one, 3 goes into 6 twice. So when we multiply all those, we have 2z. And then 5 times 6 is 30. All right, and then the next equation has absolutely nothing wrong with it. So I'm going to go ahead and just copy it down. And then for the other one, the bottom one, we just got to move that y over so that it's in the same form, in standard form, like the others. So it should be a plus 3y then after we move it over. And there'll be nothing over here. Okay, So scanning downward, honestly, we could probably go with the Y's or the Z's. I'll probably pick the Z's, but you could go with either one there, you guys. Okay, so we have equation A, equation B, and equation C. So I'm going to put definitely B and C together, right? I mean, they're already ready to go. Okay, so if we add downward, the Z's cancel. We get 7x plus 2y equals -1 for our equation D. All right. Now, as far as the other two, I'll probably pick B and C because they already have opposite signs. One's a positive and one's a negative. So I won't have to multiply by a negative, okay? So if the top one's a 2, then I want the bottom one to be a -2. So I'm going to multiply by 2 to equation B. A will stay the same. It's only equation B that I'm going to multiply by. All right, so let me copy equation A. And then 2 times B. So 2x, -2y, -2z, and -2. Okay, so we're going to get 8x minus 5y. These z's are going to cancel because they're opposites of each other, equals 28. And now we have our equation E. So we're ready to put D and E together. So let's go ahead and do that. So I'm going to do that up here, you guys, where I put D and E, just because I'm kind of running out of space down here at the bottom. Okay, so we're going to put 7x plus 2y equals -1 with 8x minus 5y equals 28. Okay, I'm thinking the y's because they already have opposite signs, and that seems like smaller numbers to deal with. So I'd like to turn them into tens, right? So I'm going to multiply the top one by a 5 because 5 times 2 is 10. And I'm going to multiply the bottom one by a 2 because 2 times 5 is -10. So let's see what our new equations are. So we have 35x plus 10y equals -5. 16x minus 10y equals 56. 5i, 10y's. And then we end up with 51x equals 51. Oh, that makes you feel good. Like, I think I'm doing this right. So we get x equals 1. And now we can take that back to D or E. It doesn't matter. I think I'm liking D a little bit better, you guys. So I'm going to go ahead and take that and put it right here. So I've got 7 times 1 plus 2y equals -1. So 7 plus 2y equals -1. We'll go ahead and subtract 7 from both sides. And then divide by 2. -8 divided by 2 is -4. And now that we have the x and the y, we're going to go back and get the z. And I wouldn't go back to the beginning necessarily because those were kind of ugly. I might go back to one of the equations that we simplified. Okay, so maybe I'll go to C. Let's see here. We'll put the x there, and we'll put the y there, and then we'll just get the z. So we have 6 times x plus 3 times y plus z equals 0. So 6 minus 12 plus z equals 0. -6 plus z equals 0. And if we add that 6 over to the other side, we get that z equals 6. Perfect. So our ordered triple is going to be 1 for the x, -4 for the y, and 6 for the z. Let me just check because I noticed that that is not what I have when I did it before on my notes. So let me just stare at it really quickly. Okay. So we substituted it into the bottom one. We got 6. We substituted a -4 in. That gives us a -12. I think it looks okay to me. Okay. Well, you know how we can find out? Let's go and graph it. Okay, so let me go plug in those originals. X minus 1/2 y plus 1/3 z. And I'm putting in the original in case I made a mistake on my simplification. So I don't want to put in the ones where I already did some math to it, because that might have been where the mistake happened. Okay, let me change the colors on these guys so we can see some contrast. Okay, so there's a great view of the point, huh? And so got 1, -4, 6, and that showed up right. So I was wrong on my notes. I'm right today. All right, so it looks good. Okay, so let's move on to a type where maybe one or more of the equations has only 2 variables. Now this freaks a lot of students out, but I would say be happy, because think about what we were doing in this process, right? We would put 2 equations together to get it down to 2 variables and put 2 other equations down to get it down to 2 variables. So equation D and equation E are equations that have only 2 variables. So it takes us a little bit of work to get it down to 2 variables. So on a question like this one, where you already have 2 variables, like this equation right here, box it and call it equation D. Okay, and this is what? Equation A and equation B, and like C really is D in this case, okay? All right, so it's like half of your work's done or part of your work's done, okay? Now you have to ask yourself, which variable is missing? Well, I can see that the Z is missing. So that means when we put the other 2 equations together, we have to make the Z go away. So you have no options. It can't be like, oh, the X's look nice. You know, it can't be something like that. It's been chosen for you. So if the Z is missing in this equation, then we have to make the Z go away with the other 2. Okay, so we're going to put A and B together. Okay. And if this bottom one's a 2Z, then we'd like this top one to be a -2Z. So we're going to have to multiply by a -2 to equation A. All right, so -2 times 4 is -8. -2 times 2 is -4. -2z and -4. And I'm just going to copy equation B unchanged. So we're going to get to the answer so much more quickly. Part of our work has already been done for us. We're already on equation E, you guys. Look at that. Already on equation E. So now we're ready to put D and E together, right? Okay. So this is going to be us. I'll just do it down here, putting D and E together. Okay, so let me copy down D. And then let me copy down E. All right, so I'm thinking the X's would be the easiest to get rid of. So if the bottom one is a -3x, we'd like for the top one to be a +3x. So let's multiply by a +3. Okay, so these X's are going to cancel and we're going to get -22y equals +22. So we're going to divide by negative 22, and that's going to give us y equals negative 1. All right. So we've got to go back to D or E, and I'm thinking D, because if we substitute that negative 1 in right there, getting x would be pretty easy. So we've got x minus 5 times negative 1, x plus 5. So we're going to go ahead and subtract 5 from both sides. So that gives us x equals negative 2. And now we have to go in and get z. So I'm thinking equation A seems the best for getting z. So we're going to take x equals negative 2, and we'll take y equals negative 1, and we'll substitute it in there. This was the day I started writing my z's look that way. Because I remember my 2's can sometimes look like z's, so one of my teachers taught me to do that. And it has been helpful. Okay, so we'll add 10. And we end up with z equals 12. Okay, cool. That matches with what I had in my notes. So our solution is negative 2, negative 1, and 12. Okay, so shorter when one of the equations has 2 variables. Now, if multiple, like a few of them have 2 variables, then you just pick one to box. Don't stress on it. Let's say that we box this top one and we go, cool, there's equation D. Okay. All right. Which now, I don't know how you guys want to label. Normally we would say A, B, and C, right? But if we box this equation, then A is really equation D. Okay. So you have to ask yourself, well, what variable's missing? And the Z is missing again, right? So since the Z is missing, we've got to make the Z go away when we put B and C together. Okay, so we're going to put B and C together. Now the key here is to line them up properly. Like we're going to need some spaces. So on equation B where the Y would be, I'm just going to leave a little bit of space. So that way I can stack these two on top of each other and still have everything lined up. Okay. All right. So then look, the Z's already cancel. I love this problem. Okay, so this is going to end up being 3x plus y equals 33. And this is equation E. So we're ready to put D and E together. So if we put D and E together, let's see what happens. Well, it'd be nice to get those y's to go away. So let's say that we multiply the top equation by a negative 1. Then that's going to change the sign on that y, right? So we'll have negative x minus y equals negative 19. And now you can see that the y's are opposite of each other. Okay, so we're going to get 2x. Those y's are going to go away. And then negative 19 plus 33, is that 14? I think it is. All right, so we'll divide by 2. We get x equals 7. Great. So now we can take that back to D or E. I'm leaning towards D because that'd be really easy to get the y. Actually, both would be fine. They're not too bad. So if we substitute it in there, we get 7 plus y equals 19. So if we take away 7, we get y equals 12. And now that we have 2, well, this one's kind of strange. we have to get z, right? So we have to find some sort of equation that has z in it, you guys. And so it doesn't matter if we pick b that has z in it, or if we pick c. They're both going to be probably equally easy. So let's say that we pick c. Probably would pick that one just because the z is already a z, not a negative z. All right, so that would give us 7 plus 12 plus z equals 29. So 19 plus z equals 29. So we'll subtract the 19 from both sides. And that's going to give us z equals 10. So the order triple would be 7, 12, 10. All right. Okay, so hopefully you're seeing the differences between when there was 3 and when there was 2. Okay, so this will be our last one. Okay, so let's say that we just box the top equation, right? So we have equation A, equation A, equation B, and equation, sorry, my pen's lagging, and equation C. All right, so if we box the top equation, then that's also going to be our equation D. So we're halfway there. So we're going to put B and C together, and we're going to make, let's see who's missing. The X is missing, right? So we're going to have to make the X go away. So if this one's a 3X, we want this one to be a negative 3X. So we're going to have to multiply by a negative 3 to equation C. So B, I'm just going to copy as is. 3x minus 2y. And I'm going to leave a little space where the z should go, so everything's lined up. Now, negative 3 times x is negative 3x. There is no y, and negative 3 times 3 would be negative 9. And negative 3 times negative 8 would be 24. So I'm just distributing the negative 3, you guys, to that equation. Okay. All right. So if we, I don't know why I chose red. Let's see here. So if we add downward, these cancel, and we get negative 2y minus 9z equals 24. And that's going to be our equation E. So now we already have D and E. So let's go ahead and put those together. All right, so let me recopy D. So it is, I'm going to put it in order. You see how it's like out of order? The Z is first. I'm going to put the Y first and then the Z. That way they will line up when we stack them. Okay, so I'm thinking about getting rid of the Y's because the Z's seem a little tough. So if the top one's a 4, I want the bottom one to be a negative 4. So I'll just multiply through by a 2. Here we go. So 2 times negative 2, negative 4. 2 times negative 9 is negative 18. And 2 times 24 is 48. Okay, so these cancel. We get negative 13z. That's 53, 52, just kidding. And we'll divide by negative 13. So we get that z equals negative 4. So now that we know z equals negative 4, we can go back to basically any equation, right? So I'm thinking about substituting it in. This is kind of out of the ordinary. We could substitute it into E, and maybe I will. But I'm also going to substitute it in to this equation to help me get x. So x plus 3 times z equals negative 8. 3 times negative 4 is negative 12. So we're going to add 12. And we're going to get that x equals positive 4. Okay. All right. So then now we just got to get the y, right? And you could really go anywhere to get the y, you guys. Doesn't matter. So I don't know, let's say that we do this. What if we substitute the x in right there? Because that equation has a y. So 3 times x, so 3 times 4 minus 2y equals 0. 12 minus 2y equals 0. Take away 12. And divide by -2. So we end up with y equals 6, okay? All right, so our order triple is going to be 4 for the x, 6 for the y, and -4 for the z. All right, number 5, special cases. So these are going to be the situations where we don't get an order triple. We either get no solution or infinitely many. So let's take a look at those. Okay, so we have our equations A, B, and C. This is a tough one. I think maybe if I were to pick, I would probably pick the z's, although I think the y's would probably be equally easy because of this 1 in front of the y. But let's say that we decide to go with the z's, okay? All right, so then I can put A with C. They're already both 2's. I would just need to multiply by a -1 to one of them. Doesn't matter which one. So let's say I multiply the bottom C by -1. So when I write C down, I'm going to change all of its signs. Okay, so let me change all these signs. And we'll add downward, and then those z's will go away. So we have -7x plus 7y equals -21. So that's going to be our equation D. All right, so now let's work on getting equation E. So it really doesn't matter which ones we pick, but I might pick B and C just because they look like they have smaller numbers, okay? So let's say that I do pick B and C to put together. If this one's a 4, then I want this one to be a -4. So I'm going to have to multiply by -2. Remember, if we got rid of the z's on the first one, we have to get rid of the z's on the second one. So I'm going to write equation B with no changes to it. And then I'm going to multiply by a -2 to equation C. Okay, so then the z's will cancel, and we get -3x plus 3y equals -9. So there's our equation E. So now we're going to put D and E together. Oops, I forgot the negative on the 21. Okay, so doesn't matter what we get rid of. Let's say that we choose to get rid of the y's, for example. So if I multiply by a 3, I'll get a 21. So I'll need to multiply by a -7 to make that a -21. So let me go ahead and distribute here then. You're probably noticing some strange stuff happening here, right? Everything's going to go away. So if we end up getting 0 equals 0, then that means that this is going to be infinitely many solutions. And we talked earlier about how this isn't enough, okay? We actually want to go in and we want to describe the infinitely many, okay? So what we're going to do is we're basically going to come up with a point, an ordered triple, right? An x comma y comma z. But instead of them all being different variables, we might pick one variable to fix, and then the other two will have to be written in terms of that same variable. So to give you some examples of what I mean, like maybe you'll fix the x, and so these other two have to be in terms of x's also. So I'm just making some junk up right now to show you that everything has to be an x. And it doesn't have to be x's. It could have been that you decide to fix y. It all just kind of, or z, just depends on what you're given and what's going to be the easiest to isolate, okay? All right, so let's say, now how I pick. I usually go to D or E, one of the equations that has two variables, and I'll start there. So let's say that I pick equation E because it has some smaller numbers in it. To me, it seems like it wouldn't be that bad to get the y by itself. So I'm going to choose to get the y by itself. So if I move this x over to the other side, it'll be a positive 3x. And then I'll go ahead and divide by 3 to everybody. So now what I have is I have y in terms of x, okay? So this y in terms of x, I'm going to substitute that in right here. So in other words, what I'm doing is I'm choosing to fix the x. In other words, I'm going to get everybody in terms of x. So the only thing I'm missing is z in terms of x, right? So I'm going to go ahead and have to find z in terms of x. So let me go to an equation, and it doesn't matter which one, okay? Let's say that I just pick c, because of all the equations in the beginning, c seems to be, I don't know, have the smallest numbers to me. So let's say I pick that one, okay? So 4x minus 2y plus 2z equals 2. So what we're going to do is I have to try to get z in terms of x, okay? So I'm going to go ahead and try to replace this y with what we know y is. Y is really x minus 3. So if we distribute, we're going to get negative 2x and then plus 6. So now it's our job to solve for z, because it's z that we're looking for up here in our ordered triple. We already have x, we already have y, so now we need z. All right, so let's go ahead and combine these. So we got 2x plus 6 plus 2z equals 2. We'll go ahead and subtract the 6 from both sides. So then we'll move the x over, making it a negative 2x. We're on our last step. We'll just divide by 2. So then what we get is z equals negative 1x minus 2. Oops. So this is what we're going to substitute into the z spot. So we're going to have negative x minus 2. Now, MyMathLab, I think, just writes it like that, but really we should use set notation. We're going to say the solutions are, we know there's infinitely many of them, are going to be points of this form such that x is any real number. I thought I could fit it. Let me see if I can make this a little bit smaller so I can fit that. There we go. Okay, such that x is any real number. Now in math, another way to write that is to say this is the symbols that are saying the same thing. That bolded R means the real numbers, and then this symbol means an element of. So x is an element of the real numbers, okay? Now let's talk about what this means. So this is going to be the answer. So I'm actually going to box this because this is more descriptive. So what does this mean? Okay, so let me go to a new slide here just so that we know what this means. When we say the infinitely many are going to look like this, we're saying we're allowed to pick whatever we feel like to plug in, as long as it's real. We can't be plugging in any imaginaries, okay? So let's just pick a few points to substitute in. That'll be easy. So let's go ahead and say let x be 0, for example. So this will be 0, 0 minus 3, 0 minus 2, right? So that's going to get us 0, -3, and -2. If we were to substitute in x equals 1, and I'm just randomly picking these. I mean, I could pick 0.5. I just don't want to do the math with 0.5. So I went for the two easiest numbers, right? Oops. So this one looks like it's going to be 1, comma, -2, -3. Now what these are is this is generating points that are going to be on the intersection. So let's go look at a picture for this, okay? It's going to make it all make sense. Oops. Okay, so the original equations that we had are -3x plus 5y plus 2z equals -19. Let me go in here and get the colors of these guys. To our typical red. All right. So the infinitely many. So hopefully you can see when I turned it sideways like that. Hopefully you can see that all three planes intersect right here on this line. The purple, the green, and the red all touch there. Look at that. Okay, so when I type in the points that we just got, which, gosh, I don't remember what we got. So let me go look back, okay? We got 0, -3, -2. There you go. It showed up right on the intersection. And then the other point that we got was 1, -2, -3. And it's showing up on the intersection. So this is a way to generate the infinitely many, right? This is a way to show people where exactly the solutions lie, okay? Sorry, I like to give you all different kinds of angles in case one you see better than the other with your eyes. Okay. All right, so it's so much more descriptive than just saying, well, there's a lot of them. You know, we have this way where we can generate all of them. Okay, let's take a look at another example. Okay. All right, so we have equation A, equation B, and equation C. Gosh, none of them look super easy, but maybe I'll pick the x's just because this x has a 1 in front of it, so that makes it kind of easier. So let's say that we put, why am I putting A and B together? Just kidding. A and C together. All right, so if this is a 4x, then we'd like for this to be a -4x. So we're going to multiply by a -4 to equation C. All right, so A is unchanged. And then if we multiply by a -4, we're going to have these x's canceled. So we get 18y plus 17z equals -14. And that's going to be our equation D. And now I'll probably put B and C together. So I still want to use that 1 on equation C. So if this is a 3, then I would like for this one to be a -3. So that's what I would have to multiply by. All right, so B is going to be unchanged. Oops, let me get the color black. Okay, and I'm going to multiply by -3 to the bottom equation, hopefully correctly. Okay, so the -3x and +3x are gone. And we end up with 18y plus 17z equals -11. And you might be seeing some strange stuff kind of happening already. Okay, so let's see what happens when we put D and E together. So if we put D and E together, and it really doesn't matter who we pick to get rid of, right? Okay, let's say that we pick the y's to get rid of, okay? Then I might multiply by a negative to the bottom equation. So that'll get me -18y minus 17z equals 11. And both of these cancel, so we get 0 equals -3. Now this differs from the last one. 0 equals 0 is a true statement. This one is a false statement. And so this would end up being no solution. Now I do realize that I think I forgot to classify these, right? So let's go in here and classify these. So remember, if it has no solution, it's inconsistent. And since it doesn't have infinitely many, it is independent. Okay. All right, so then let's go in and get, for the last one, we never labeled it, right? So let's go in and label that. So for this one, it had infinitely many. So let me get this out of the way really quickly. All right, so since there was a solution, it is consistent. Since there were infinitely many solutions, it is dependent. Well, we can practice those and just reiterate why. Hopefully it just gets into that long-term memory, you guys. Okay. All right, example 6. So let's try a word problem. Okay. So remember, the very first thing you want to do when you have a word problem of this type is make sure you define your variables well. So as we read through this, let's kind of decide what our variables are going to be. So a stadium has 49,000 seats. Seats sell for $25 in section A, $20 in section B, and $15 in section C. The number of seats in section A equals the total number of seats in B and C combined. Suppose the stadium takes in 1,052,000 from each sold out event. How many seats does each section hold? Okay, so when you're looking for what you're going to define your variables as, you really want to go to the question sentence. That's going to help you decide, because we could put A, B, and C, and not really know what those mean, because there's multiple things that A, B, and C could stand for. A could be the amount of money, the amount of revenue taken in from section A, or A could be the number of seats. Okay, so we really want to make sure we have that down solid. So if you look at the question sentence, it says, how many seats does each section hold? So this is going to stand for the number of seats in section A. Oops, not Q. Let me make this a little bit bigger here. Perfect. And then similarly, this will be the number of seats in section B. I just noticed I have section spelled wrong there. And then this is going to be the number of seats in section C. All right. Having these defined well in your mind is going to help you set up your equations better. Okay. Okay, so I'm going to start off with the very first sentence that says that a stadium has 49,000 seats. So what that means is the number of seats in section A plus the number of seats in section B plus the number of seats in section C has to add up to 49,000. If we go to the next one, seats sell for $25 in A, 20 in B, and 15 in C. Okay. I like to call this the money equation because you want to toss all of the money into one equation. Every now and then I'll have students who will mix this up. They'll be like A plus B plus C equals 1,052,000. But there's no money involved here. There's only seats. So for this equation right here, where we start to include the dollar bills, right? $25 for section A, 20 for B, and 15 for C. Those are all the dollars. So I might as well toss in the 1,052,000 because that's also in dollars, okay? Now, if you think about what each one of these things means, A stands for the number of seats in section A. If I multiply that by $25, we're going to find out how much the stadium took in, money-wise, for seats in section A. And similarly for B and C. You add that all up, you're going to get the money that the stadium took in. You're going to get its revenue. All right, so then let's go to this last sentence here. The number of seats in section A equals the total number of seats in B and C. So A equals B plus C. Now, there's lots of ways to go about this, you guys. You might use substitution. I'm trying to make sure that I'm consistent and use the same thing all the time so that it's easier to kind of latch on to the algorithm. But if you can spot a way you like better, or maybe a more efficient way, then go for it. Okay, so I'm going to move the B and the C over so I can get these in standard form. So it's going to say A minus B minus C equals 0. All right. So let me go ahead and label these equations. Gosh, I hate to use them A, B, and C because we got so much going on. How about I label them 1, 2, and 3 this time? Okay, so I can see that I want to put 1 with 3 because look at all these nice things that are going to happen, right, with the B and the C. So I'm going to put 1 with 3, and I'm not even going to have to change a thing. So if we add downward, we get 2A equals 49,000. And then if we cut that in half, we're going to get 24,500. So that's not the money made from section A. That's the number of seats sold in section A. Or that's the number of seats in section A, because it does say we sold out the event. Okay, so we put 1 and 3 together. So maybe we can put 2 and 3 together, maybe. So let me talk about why those. They already have opposite signs, so we could make the C's go away pretty easily. So I'm going to leave equation 2 as is, but for equation 3, I'm going to have to multiply it by 15. So we get 25A plus 20B plus 15C equals 1,052,000. And then 15A minus 15B minus 15C equals 0. So we got 40A plus 5B, and then the C's cancel. And that's going to get us 1,052,000. Okay, so we have our equations D and E. So at this point, we usually put D and E together, but we're going to put them together in a different way than we normally would. We're going to substitute A in. Okay, so if we do 40 times 24,500, we're going to get 980,000. So we'll just take away 980,000 on both sides. So let's see what that gets us. So right here, they cancel. So we have 5b equals. Okay, I did grab a calculator, so I'm good to go now. So let me go ahead and subtract those. That seems way too big. So let me just make sure. Oops, I forgot a 0 on the 980. So there we go. Whew, it's gonna say that's too big. All right, so 72,000 is what I got. All right, so we're gonna go ahead and divide by 5. And so that's gonna get us B equals 14,400. All right. And you can go to wherever you think is the easiest. Probably where I'm going to head towards is the very first equation that we wrote down, the one that uses the fact that there's 49,000 seats. So I'm going to substitute B in, I'm going to substitute A in, and that's going to tell me how many seats are in section C. So 24,500 plus 14,400 plus C is 49,000. So 24,500 plus 14,400, I'm getting 38,900. So now we just got to subtract that. From both sides, and then we have how many seats are in section C. All right. So I'm getting 10,100. So there's an easy way to check these. They should add up to 49,000. So I'm going to put this into my calculator really quickly. They added up to 49,000. Another thing we could check is this equation right here, the total number of seats in B and C better add up to A. So if I put B and C together, I add those together, I do get the same as an A. This is looking really good, you guys. All right, let's try one more. The change machine contains nickels, dimes, and quarters. There are 75 coins in the machine, and the value of the coins is $7.25. There are 5 times as many nickels as dimes. Find the number of coins in each type of machine. Okay. So if we were to define our variables, I would probably use N, D, and Q, right? So N is going to stand for, let's check it out, the number of coins. Okay, so N equals the number of nickels. Oops, I keep typing. There we go. And then D is going to equal the number of dimes. And Q is going to equal, of course, the number of quarters. Okay. So I know that there's 75 coins in the machine. So that means that the number of nickels plus the number of dimes plus the number of quarters better equal 75. And again, we talked about the money equation, right? So the $7.25, well, I'm going to put a 0.05 in front of the nickels, a 0.10 in front of the dimes, and a 0.25 in front of the quarters. That way, all of the money is in one equation, okay? If you do 0.05 times the number of nickels, like let's say there's 2 nickels, 2 times 0.05 is 0.10. So you just found out there's 10 cents in the machine in nickels. So multiplying the amount each one is worth times the number of coins, that'll tell you how much money you have, at least for that type of a coin. Okay. All right, now let's go to the last sentence. There are 5 times as many nickels as dimes. So there's more nickels. So we would take the dimes and we would multiply it by 5, and that should give us how many nickels there are. This is a tricky sentence for a lot of students because they see 5 times the nickels. So they want to do 5 times N. What I always like to say is figure out who's bigger and they're going to be the one on the other side of the equal sign. You would take the smaller one and multiply it by 5 to get to the bigger. So always figure out who's bigger. In this case, it's n, and then write n equals. And then you'll do 5 times the other. Okay. Got to multiply the smaller one times 5 to get to the bigger one. Okay, so on one like this, I probably would just use substitution. Let's do that just so we've seen that. So in other words, we're going to take 5d, and we're going to substitute it in anywhere where we have an n. But before I do that, I am noticing here that I have a lot of decimals. So let me try to get rid of the decimals really fast. So I'm going to move the decimal place twice in that middle equation, you guys. Oops. N plus D plus Q equals 75. If I move the decimal place twice, it'll be 5N plus 10D plus 25Q equals 725. So that way I don't have to deal with decimals. Why not, right? Okay, so I'm going to go ahead and substitute in for the n here and the n here a 5d. Okay, so what we're going to end up having is, let me do the first equation. So 5d instead of the n plus d plus q equals 75. So we have 6d plus q equals 75. Then I'm going to do it in the other equation. So it's instead of 5n, 5 times n, which is 5d, plus 10d, plus 25d, equals 725. So we're going to get 25d, plus 10d, plus 25. I got a little crazy on the d's here, you guys. This should have been a q. Sorry for that. I confused you. Let me delete that guy out. That should have been a q. Okay. All right, Q equals 725, and 25D plus 10D is 35D. So what we've done is we've taken it from a system of 3 down to a system of 2. So now we're going to put these two equations together. So we got 6D plus Q equals 75, 35D plus 25Q equals 725. So in order to eliminate, I'm going to choose the Q's because there's a 1 in front of that Q. So that seems easy to do. So I'm going to multiply by a negative 25, and that should make those Q's cancel. So 6 times 25 would be negative 150, then negative 25Q. And then 25 times 75, 1,875, and it'll be negative. All right, then I'm just going to recopy. All right, so this will be negative 115D. These will cancel. And I am getting negative 1150. The good thing about a word problem is you will know if you've messed up a negative. You'll be like, there were negative 10 dimes in the machine. And you'll be like, okay, I've made a mistake somewhere, right? So good thing we got a negative divided by a negative, because at least we'll have a positive amount of dimes in here, right? And this looks like this is going to be 10, positive 10. Okay, so we know that there's 10 dimes in the machine. So let's go get the quarters. So if we take this and we substitute it in right here, we have 60. So 6 times 10 plus Q equals 75. 60 plus Q equals 75. So if we subtract the 60 from both sides, then we're going to find out that Q is that 15? So there's 15 quarters. And I'm going to take that D and substitute it again into what I think is the easiest equation. Remember, there were 5 times as many nickels as there were dimes. So let's do 5 times 10. And that's going to get us that the nickels were 50. Now we know we have 75 coins total. If we take the 50 nickels plus the 10 dimes plus the 15 quarters, we get 5. And then there's our 75. So we have the proper amount of coins. Okay. I'm sure if you check the monetary value for each of these, that it would add up to $7.25. Let's see here. So if we do 15 quarters times 0.25, so that's how much a quarter's worth, we get $3.75. We take the 50 nickels and we multiply that times 0.05, we get $2.50. And 10 dimes would just be $1, right? So we end up with 5, 12, carry the 1, $7.25. It checked out. Perfect. So it's kind of nice to have a word problem because you'll be able to catch a lot of those little mistakes that we all make. All right, you guys, this is a really tough section. If I could give you some advice, it would be go slow, write neatly. Usually my students who are fast and sloppy, they struggle with this section so much. And then the number one mistakes that happen are students copy equations down incorrectly from like one spot to another. So like maybe this one right here, when we copied it here, like you accidentally copy it down wrong. So double check that you even copied it down right, because that's a main mistake that I find. And then whenever you're multiplying and distributing, a lot of students forget the last number. So they'll distribute, and they'll just leave this last one and won't distribute. So those are the two main mistakes that I see students making. They copy it down wrong and they forget to distribute to the last term. Okay. So if you can watch for those, that'll up your likelihood that you'll get this right. And go slow to go fast. People who go fast make lots of mistakes and they end up doing the problem 2-3 times. People who go slowly actually end up being faster because they only do the problem once. So it's just something to think about for those of you like me who are really messy and try to do things fast. That really explains when you can see my writing and how much I struggle with being neat. So I'm only speaking to you from experience, okay? Go slow and try to write your neatest if you can. All right, thank you so much for joining me, you guys. Good luck on this section.